Car fleet. There are n cars going to the same destination along one lane road. The destination is a target miles away. You are given two integer array position and speed. Those are the two areas which they have given, that is the position and the speed, both of length n, and they have also given target to reach. They have also given target to reach that particular destination. A car can never pass another car ahead of it, but it can catch up to it and drive her bumper to bumper at the same speed. The faster car will slow down to match the slower car's speed. So, over here the thing is, if you have a simple example I can share with you is, suppose you have a car which has a speed of say 20, and a head car has a speed of a 10 or anything, okay? Then this car at some point of time is going to collide with the ahead car. And what they have given, a car can never pass another car. So this car can never pass another car which is ahead of it. So the destination is over here, target is over here. Suppose the target is, you're taking, let me take this target as 30. Okay, let's take the target as 30. So the cars are moving over here. This is the ahead car. So at some point, this car is going to collide with this car. And that's the reason the speed of this car is now going to become 10. Because when they collide, they are going to become a car fleet. Basically, they are going to join together and then go to the destination. So this becomes a car fleet. This is called one car fleet, wherein this car is going to collide with the ahead car and go in the same speed as of whatever is the ahead car's speed. That is called as a car fleet. This is a car fleet. This is a simple example to make you understand about the lines. A car fleet is some non-empty set of cars at the same position and same speed. Note that single car is also a car fleet. Even a single car, if it is present, then that is also a car fleet. Return number of cars that will arrive at the destination. To understand this simple, I have, so they have given this two arrays, right? The position array and the speed array. I'm going to combine it in one format, and let's take the arrays as, suppose this is the position and this is the speed, then this is the position, then this is speed, this is the position, and this is the speed. So this is one combined array which all has a position and which has a speed. So let's draw a little understanding of the car fleet. This is a time axis and this is the position axis. Now first thing is, they have, this is one, two, three, four, five, and then the position we have three, we have five, we have seven, and we have 10 as our target. Let's take the target as 10 over here. Okay, now the first car, that is the third car, is going to go till the, it is going to move till the target position, that is at the 10th speed. And the time, we have to calculate the time obviously, but that time there is a calculation of the time. It is like target minus position divided by speed. That will be coming it later, little later, so we can do that later, but just try to understand this particular part. Here you can see, so suppose time is around 2.5 or something like that. Here you can see it is reaching the target at this particular position, right? Then next, let's try to take the next car. The position of the car is 5 and the speed is 2. So this I'm taking a different color. uh, so now this car is going to move, this car is going to move in this direction. Now, if you see green green line, right? Green line is getting intersected it is getting intersected before even it reaches to the target. The green and blue are getting intersected before even it reaches the target. That's the reason this becomes a car fleet, because green is going to go at the speed of 5 itself. It is going to take the speed of 5 because 5 is ahead of it, right? 3 is behind. So ahead of the car, they are going to take the speed of the same car, of whatever the car is ahead of it, that speed it is going to take and reach the destination. So this becomes one of the car fleet. Next, let's see 7 and 1. If you see 7 again, if you draw with a different color, so 7 is also going to reach the destination, and it is also going to have an intersection point. Again, it is going to have a car fleet because it is intersecting and it is ahead of it. So all these cars are going to become a car fleet, and there will be one car fleet. This is just a presentation to show you how they intersect when going with the speed of that, and how they are becoming one car fleet, because they are intersecting. Blue and green are intersecting, then red and blue are intersecting. So at the end, when they reach the target, they are going to go at the they are going to go with the same speed and having only one car fleet, because they are intersecting together. This is one of the little understanding of this particular sum. Next, let me show you a little more what we are going to do. So as I said, I have position and speed array combined. So basically, these are the cars, okay? These are the cars. Here is the car of 7, here is the car of 5, here is the car of 3, and here is the target destination, that is 10. So now this car has to reach to 10, right? So we have to calculate the time of 7 car to reach at 10. How to calculate the time? That is 10 minus 7 divided by 1, means it is taking target minus position divided by speed. So that becomes, this is the position and this is the speed. So that becomes 3. The time becomes 3, because 10 minus 7 divided by 3, divided by 1 is 3. So at time 3, it is going to reach the target position. Now when you're coming to over here at 5, we have to calculate same thing. The current time we have to calculate of the fifth car, the car which is at the fifth position. So same target minus position divided by speed, that is 10 minus 5 divided by 2, that comes to 2.5. Now you see over here, this car, whenever it is moving at speed of 2 and 7 is moving at speed of 1, so somewhere down the lane, this car is going to intersect with the this car is going to intersect with the seventh car. At some point of time, this fifth car, the fifth position, is going to intersect with the seventh position. You can see the speed of 7 is 1, the speed of the earlier car, the before car, is 2. Why it is that? Because always we have to keep the first one ahead of it. That means the ahead car will always be the first one. It is not. So you know what, this is going to intersect with this, but this car is never going to intersect with anyone, because there is no cars ahead of it. Directly it is a target, right? So always this car has two timings, I mean two speeds. One is the speed of 2, which is of itself, and one is the speed of 1 when it intersect. That's the reason we have to check, like the before car, where it is intersecting and when it is becoming the car fleet. And that is how this car is going to intersect and become one car fleet, and at some point of time it is going to get the speed of 1 which this car has, and then it reaches that particular destination. So in this mathematics, I just wanted to let you know that whenever there is a less time whenever there is a less time than the ahead time, we are going to remove that car, because at some point of time it is going to collide with the ahead car. um Same thing, we are going to calculate the current time of the position 3, that is 10 minus 3 divided by 3, which becomes 2.3. And same thing, this car is going to collide with this particular car, and then this car will be having the speed of this car, which is of 2, and then it is going to collide with this, which is again having the speed of 1. So these all cars become one car fleet, and since the time is less than the ahead car, we are going to remove this car as well and say that this is going to be a car fleet. One thing, I'm always traversing this cars from backwards. If you observe it, I first resolved the car of 7-1, then I came to 5-2, and then I came to 3-3. There's a reason behind this, the same reason, because see, if you are traversing from ahead, right? If you're traversing from in this direction, from front direction, you can calculate about for this car. But what about this one? Because this one, let me take another color to explain you. This car is having two speeds, right? This car is having two speed. One is the speed of itself, and one is the speed of ahead of the car. So then there will be a confusion if we traverse from the front end. That's the reason we are traversing from back. That's so that we know that this car is going to collide with the ahead of car, and the speed is 1, and that's how we can calculate and do our mathematics for the last remaining car, and that's the reason we are traversing from the backwards. So for this for doing this, we need a data structure that is of stack data structure. We can use it wherein whatever cars, or this is my stack, so whatever cars, like I'm starting from back, so seventh car is coming here. I'm calculating the time of the seventh with the help of target minus position divided by 1, which is coming to 3. Then next car comes, which is 5. Again, I'm calculating the time over here, same. So I think which is coming up to 2.3 or something. So the if time is less than the ahead of time, then I'm going to pop this particular car and say that it is going to collide with the ahead car, that is the seventh car. Next comes the third one. Again, I'm going to calculate the time, which is again target minus position divided by speed. So again, it is 2.5 or something like that, and this is again going to collide with the this is again time is again less than the ahead of car, so it is going to collide with ahead of car. That's the reason we have to pop it off from the stack. And then to return how many car fleets, we are just going to say whatever the stack dot size, we are going to return that as a our car fleet. Time complexity, it is O of n time complexity, because we are traversing this array, and space wise O of n again, because we are using the stack. Let's see in the code, static and car fleets in position, in speed, in target. If position dot length equal to or greater less than 1, then return less than 2, I can say. If it's less than 2, then return 1. And first thing is I'm going to combine it, right? So I'll just have a traversing array on the position. I'll traverse on the position array, position dot length plus plus. Before even that, I will be initializing the combine array, where I'm combining both position and speed. New int position dot length to. Next is I'm going to initialize this of ith of 0 index with position of I, and then the second index, that is the first index of combined array, ith of 1 with speed. And once this is done, I am going to say arrays dot sort um, combine. So yeah, I think time complexity will be O of n log and not because we are doing a sorting. So it's not going to be O of n time complexity. Next, we are going to say for int of I equal to traversing from back, combine dot length minus 1, I greater than 0, I minus minus. We'll say while stack is not empty. Oh, I have not initialized the stack. Stack integer stack equal to new stack. So while stack is not empty, and we have to calculate the current time, right? In current time equal to target minus combine I of 0, that is position, divided by combine I of 1, that is speed. If current time is less than the stack dot peak, then what we are going to do? We are going to pop it, stack dot pop, or else we are going to push, stack dot push the current time and return stack dot size. We are going to return our stack dot size. Sorry for that, I'll have to put the charger. So return stack dot size. Yeah, this is all about it. We are calculating here current time. If it is less, we are going to pop it, and at the end, whatever the size of the stack is there, we are going to calculate it. And I forgot to mention about the sorting, which is important because if it's not sorted, then we cannot get that traversing from the back. So we have to do the sorting of that combined array, which we are inserting the position and speed together. So we have to sort that. Thank you for watching.